In this video, we're going to consider the limit as x approaches 2 of x squared. Given an epsilon of 0.5, we're asked to find the corresponding number delta from the definition of limit. Well, this limit's easy enough to evaluate. It's a polynomial function, so I can just substitute in. And now, I think f of x minus L is supposed to be less than that number epsilon. And I can work through this the same way we've been doing. I need to add 4 to everything. 3.5 is less than x squared is less than 4.5. And now to get x by itself, I would need to take the square root of all of the pieces. And here, just for a moment, here are this is the exact interval on the x-axis that would work. I need to keep 2's in the middle. I need to keep my x's between the square root of 4.5 and the square root of 3.5. Delta is a distance, and I could actually do this exactly, right? The distance between 2 and the square root of 4.5 is square root of 4.5 minus 2, that's a number. And then the distance here is 2 minus the square root of 3.5, and then I'd get a number. My question here is whether, I don't think this is that case we've been dealing with where I get the same number on both sides, and it's a delta, so I would need to remember to find the smaller one. And I notice this kind of trailed off the bottom of the board, sorry about that. So I want to find a decimal approximation for these two values, but I want to talk about being very careful with that. So I'm going to take my calculator. I'm going to find the square root of 4.5. And I get 2.12. And if I was to round this to 2 decimal places, 2.12 is what I'd want. And that rounds normally. But when I'm dealing with these intervals, I want to make sure I'm always making them smaller, which means even if that was a 2.125, I would still just write 2.12 because I don't want to go any bigger. My x's weren't allowed to be bigger than this number. So on this top interval, I need to remember always to round down. The square root of 3.5, 1.87, and here's where I have to be very careful. If I was to round that to 2 decimal places, the typical way I write 1.87. And that would actually be a little bit less than. It would be outside of my interval. So I'm actually going to choose to call that 1.88 because I need to make my interval smaller, not bigger. If I relax this to 1.87, I'd be letting x's in that don't work, that don't keep me within 0.5 of 4. All right, so when you're rounding, the top has to round down and the bottom of the interval has to round up. And what I see now is by that special rounding, I can calculate a delta. The distance between here and here is 0.12, and coincidentally, that's what I get here too with that special kind of rounding. Delta is 0.12, that positive distance. When epsilon is 0.5, delta is 0.12. If you ever choose to round delta, that distance, you would have to round delta down. Being more conservative with delta is better than making it too large. If you make delta any bigger, you'd include x's that don't work.